Okay, welcome back to Gold's Garage. So this video is all about Will Casey's small block 350. I think we titled the first video the worst 350 ever, and that wasn't really fair. Lots of good comments I got from that video from guys saying I got a worse 350 than that. So yeah, good point. Anything from getting into the early 70s till fuel injection became dominant in the 80s, pretty much the same thing. Low compression, small cams, small heads, and then eventually fuel injection. So, but once again, once you get it apart, it's all the same. So before I go forward, we're going to do today, Alec will just scan it for me. We've got all the parts ready, available. We're going to go through all that, show you all the parts that we've got, what the process is, what I've done to the block, preparing it, go through the detail of that, and tell you what else is going on in Gold's Garage. So before I get doing that, because I usually forget, please like and subscribe. Thanks very much for all my new subscribers. We also just made a video yesterday with Bill Little on his Cam Doctor. It just got published this morning. Mike got it published for me this morning. It's going really good. And if you want to take the next level of knowledge about how camshafts work, watch that video, because Bill, he lives at a different level, that's for sure. And it's really, really good information. If you're interested enough to really understand a camshaft, you'll enjoy watching that video. So first of all, let's talk about what else is going on. So we made videos before about the Pontiac, the demise of the Pontiac engine, where the intake, the bolt that holds the air breather on, found its way into the engine and basically broke it. So Joe bought another block and another set of heads and a whole bunch of other parts, and he's got them at the machine shop now. When he gets that back here, I'll be disassembling this engine, salvaging some of the parts. Joe's got new pistons and rods for the other block as well, but we're going to take the accessories off this engine, the camshaft, etc., check all that out, and basically rebuild his 400. It was a 455. The new one's going to be a 400. Mike Kimball's small block has been sold, and the buyer is going to use the World Product steel heads. I'm going to put them back on, and we're going to dyno that engine again, so watch for that, another dyno. We'll see what difference it makes. We made 352 with 2 leaking valves on the first try. We're going to have a good set of heads on it and go over there. And then my 406 that we dynoed 2 weeks ago, they made 503 horsepower and 527 foot-pounds of torque, is still for sale. I got some interest, but it's not sold. And I got it on the test stand so I can demonstrate it. I can start that engine up right now if I wanted to and demonstrate it for somebody. But there's a good dyno video of that 2 weeks ago. I think it's got 11,000 hits or something like that. So you probably would enjoy watching that if you want to know more about it. So back to the engine. We're going to talk about all the parts and all the things that we did. I just want to make a couple points. First of all, one of the things on a budget build, if you can avoid going to a machine shop. And let me say this. Machine shops provide a necessary and essential service that we will need now and forever. On many engine builds, there's a lot of machining that has to be done. But if you have a good block that's not worn, it doesn't need to be bored, and a good crankshaft that's not worn and doesn't need to be turned, then you have a candidate for a budget build where you don't have to do that. And the other issue with machine shops, most of them are run by guys as old as me, who've been around for a long time, who have a deep wealth of knowledge and experience, and can be very, very helpful for you if you need to go to a machine shop. And normally, if we'd have had this block board, we'd have taken it to the machine shop and had them do the cleaning of it as well. They would hot tank it, and basically a dishwasher for engine blocks, sit overnight with a high temperature acid bath, and it would come out there squeaky clean. So, but we didn't do that because we didn't need to bore the engine, so bore the block. So Will's block had virtually no wear in the cylinder walls. and the crankshaft is good as well. So we did not use any machine shop services, but there's 4 or 5 really good machine shops in this area. I've used them all at one time or another, and I will use them again on builds. But so here's the block. The last time you saw this, if you watched the previous videos, it was all grungy and dirty, and I spent a lot of time cleaning, grinding, scraping. I have a very high pressure power washer device that is really good. And the other thing we use on cleaning a block, I have a Moroso kit that has every size of, I'm looking around here trying to find the smaller one, but in the Moroso kit, let me just show you quickly. I thought I had one out, but there's every size of brush you can imagine for every orifice in your engine or in your block, in your crankshaft, all the oil holes, etc. And it's a good way to really get it clean. I also used, Mike wanted me to mention this, that's Totally Awesome cleaner. And this is pretty economical stuff. He buys it by the case. It's a great grease cutter. So I use this. I used Varsol and other cleaners. Scrubbed, re-scrubbed, took a long time. Because if you've seen this block before it was cleaned, it was pretty grungy. And I can tell you right now, all the orifices are clean. I've flow checked every orifice, so I know it's ready to go. I'll show you from the other side. It looks clean as well. So cam bearings are knocked out, frost plugs are out, all the oil plugs are out. I mentioned in the last video removing all the oil plugs. So one of the brushes that I use actually goes all the way through these orifices here. This one feeds. These two feed the valve lifters and the camshaft, okay, for your hydraulic valve lifters or solid. And this one is the main artery that feeds down into your cam bearings and into your crankshaft. So a small block does not have what's called priority oiling, which means the oil goes to the camshaft before it goes to the crankshaft. That's not a bad thing. So the oil goes in the camshaft bearing, there's an annular groove, comes back out and feeds the main bearings of the engine, and the main bearings from the crankshaft feed the rod bearings. That's kind of how that works. So everything's been knocked out. There's nothing in this block now, so the first step. The other thing, I've honed it. So I hand honed it, and there's another comment. If you had to go to a machine shop, I'd much rather have a nice professional hone job on a Sun honing machine that can give you a precise finish, or some of them are computer controlled, and that would be preferable. But if you're not going to a machine shop, you got to do it yourself. So I have a hand hone and start off with a 400 or 220 grit stones to, we're not trying to take any diameter out of the block, and just some people use ball hones. A ball hone will follow the bore. It won't stay parallel. These hones stay parallel. But we're not taking any material out. We're just putting a new finish on the block. The crosshatch, the idea of the crosshatch is to carry oil up into the cylinder to keep it oiling. There's a path for oil to get, and to give a place for the rings to seal. So 220 grit, first of all, to cut that surface, and then I finish with a 400 grit. So the 220 grit makes the little mountain peaks, and the 400 grit cuts the peak of the mountain off, basically. So you've got grooves to carry your oil. You don't have the peaks. So that's how we do that. And once again, it's one of the issues. If you want a budget build, it's not as nice, but we've had pretty good luck. The measure of that is when you do a leak down test, how well your cylinder, your piston seal, and we usually get pretty good numbers. So we're happy with that, and we'll continue to do that on budget builds. If I went to a machine shop, a lot of times they would actually hone it with an engine plate on it. This is about a 2-inch thick plate that bolts to simulate the head. So when it's honed, it's taken into consideration all the stretching and the stresses that go on when the head's bolted on. So, but for a budget build, it's going to be fine. And we also lightly hone out all the lifter bores. And this is the tool that we use for that. It's just a little brake hone. Okay, you don't go crazy. You don't need to take a bunch of material out. You just get in there and make sure there's no rust or grooves or anything in there. And when the engine goes together, I'll put a lifter in every bore at a time with my fingers and rotate it and make sure that lifter can freely rotate in the bore. And if it doesn't, we'll keep honing till it does. So that's how that works. So what's got to happen first when I start, put the thrust plugs in, put these oil plugs, they all got to be sealed, okay? In the case of the front ones, sometimes people actually drill a little hole in the plugs to drop a little more oil on your, this surface here is where the thrust of your timing gear goes, and to oil the timing gear. I don't think it's necessary to do that. They're getting lots of oil from natural flow, but it's something that some people do. And you got to permanently seal with a Permatex sealant. I don't have that in my hand right now. To make sure that the back blocks, you definitely don't want any leaks because it'll leak oil back into right onto your flywheel. So all that stuff's got to go. All the plugs got to go into it. Cam bearings are next. So I've shown videos about how to put cam bearings in before. We may do that again. The cam bearings go in next. I always like to put the camshaft in first. You don't necessarily have to, but it's nice to get the camshaft. It's easier to manipulate the camshaft when there's no crankshaft in the engine. If I can't do that, I'll use a dummy cam to make sure at least that the cam bearings are nice and square and straight and we don't have any issues with binding or anything. So, and it's been painted. So to paint, we use a high temperature gray primer first. After it's clean, let that settle overnight to make sure it's stuck on pretty good. And then this paint, these engines, this 81 Corvette engine, and there was a whole series of engine. I had a 75 Corvette. It had a blue engine. I forget, I'm not sure what years they started and stopped, but a lot of Chevrolet small block engines in those kind of cars were blue, and Will wanted it to look original, so that's the blue color that it was painted with, and so we painted with that again. So that's it, all I can think of for the block at the moment. So let's get on to the parts that we've got so far. We've got almost everything, and I'll explain where that stops and starts. Starting with, let's see, where did we start? Cam bearings, Durabond cam bearings. There's other makers that Perfect Seal makes cam bearings. So these are pretty common, Durabond CH8 cam bearings, and they work just fine. There's videos about how to put them in. It is important to clock them. Typically, the main feed of the bearing goes in, or the oil hole. So the oil goes around this annular groove. Maybe Alec, got my good friend Alec help me here again today. Thanks, Alec. So there's an annular groove there, and then there's a little hole in the cam bearing that allows the oil to get in between the cam and the bearing. So we clock that hole usually around 2 o'clock. And the idea of that is the oil enters there and creates a wedge as the camshaft is rotating, and that wedge helps to float the camshaft off the bottom and keeps oil between the cam and the bearing, which is the idea, right? So that's one of the things that goes in. If you're going to fill, one of the other things we're going to do with the block, I forgot to mention, these holes here come with pressed in plugs. So we will put threaded pipe plugs. So you got to buy those as well. So we'll drill or not drill, you don't need a drill. The tap size is already right. 1/4 inch pipe tap. One of the things you have to be careful if you decide to do this yourself, on the center one, you got to tap it in very, very shallow. If you get yourself tapped in too deep, the oil hole that feeds this bearing is going to get blocked off, and you're not going to get oil to your front main and your front camshaft bearing. So you don't want to do that. So you have to make sure that you check that and measure that. Don't get it too deep. And then I actually measure the flow. I put oil in there and make sure that I have good flow before. I've seen cases where guys have done that and they actually plugged off the front main bearing by putting that too deep. So be careful with that. With these two, it doesn't matter. You're a long ways away from blocking off any oil travel, so it won't be a problem. So that's it for cam bearings and plugs. New frost plugs. So somebody commented on a previous video why I didn't use brass. I usually do. I probably had some steel ones. But for what it's worth, guys, the brass looks cooler, but the steel ones probably last 50 years, so that's good enough for me. But brass looks nicer. So I always paint it first, then put the plugs in so you see the nice contrast with the blue and the brass. And this kit comes with some of the plugs, but not enough to fill the front 3 holes. So that's why we do that. So next thing, the crankshaft. So the crankshaft, we didn't have to buy one. The 2 main things we salvaged from the original engine, the block and the crankshaft. The crankshaft is fine, and we're going to reuse it. We bought standard bearings. We're not going to turn the crankshaft. Okay, so that's not going to be a problem. One of the things we have to do with the crankshaft, though, and as soon as I find that part, here it is. So almost every small block Chev crankshaft where the rear main oil seal runs, you can just show that right here, Alec. This little space right here, that's where the rear main oil seal runs. And this one's really good, actually, but a lot of times there's a little groove there, and that groove is exactly where your seal travels. So if you just change your seal and it goes in the same place, it's going to probably leak on you. And leaking rear main seals, small block Chevrolets, is pretty common. So if you use this seal, BS 11829-1 Felpro, it's actually a Felpro seal made to move the location of the lip of the seal over, I think it's about 50 thou away from that groove. And so you're running on a new part of the surface. Now you're not going to have a leak. So I use these pretty much exclusively. This crank looks so good that I probably could get away with not doing that. But for what it's worth, and speaking of that, we don't buy a complete gasket sets, because if you buy a complete gasket, you get a whole bunch of stuff that you're not going to probably use. We're not going to use the head gaskets. We're not going to use the pan gasket. We're not going to use the main gasket. So it's not worth buying for a small block Chev the way I do it, buying a gasket set. Buy your gaskets individually and you won't have a whole, I got boxes of leftover gaskets from jobs that I never got to use. So, but that's something worth thinking about. They're not that expensive, and almost for sure you will not have a rear main seal oil leak if you do that. So that's pretty much it. I think with the block, it's going to look really nice. So the heads, we'll come back to it. We're going to talk about these heads because there's lots of controversy. These are my Chevrolet fast burn heads. And people saying if it's an economy build or a budget build, what are you wasting your time putting those expensive heads on? Something like that. That's a good point. And if we had to go out and buy these heads new, I think they're about $1,300 US each new. So it would be prohibitive and you wouldn't call it a budget build. I happen to have these heads off one of my Pro Late model race cars. And so they're in stock. I can sell them to Will for the same price as he could buy Speedmaster or Pro Max Chinese heads, I guess we'll call them for now. There's nothing wrong with those heads, by the way. They work just fine. And I've used lots of them. They take a lot of criticism, but most of the time, in my experience, they work pretty good. Bill Little has flowed these heads. They make 258 CFM at half-inch lift. Yes, more head than you need for this engine. It's more head than the camshaft is going to support, but it's not going to hurt anything, and it's the same price. And they're GM heads, and we'll like the idea that we're going to use GM heads. They got beehive valve springs, which are the ultimate. All the new LS engines have beehive valve springs. You will not get into valve float with this camshaft with beehive valve springs. So, and I have already leak tested them, and they're okay. So they're ready to go. So Will had to think about it. I give him a choice to buy new Pro Max heads or these, and he decided he wanted to go with these, and that's fine. That's what we're going to do. And that's the reason why. So back to parts. I'm jumping around a little bit here. I'm sorry. So you got your crankshaft. Now about pistons and rods. So originally we had planned to use the old pistons and rods. And once again, customer choice. We consult with Will, and he decided It's a little bit more money, obviously, to buy new pistons and rods. Mainly we wanted the pistons because the pistons that came in this engine, one of the reasons that it only had 8-to-1 compression ratio because it had dish pistons. So we had to buy pistons if we wanted to get the compression up. So these pistons are 6.9 cc's combustion chamber volume, and the other ones were, I think I've mentioned a couple numbers, but the actual calculation I finally did is 14 cc's. So that gets our compression ratio up to, we can easily get 10-to-1 compression. So now you're going to buy pistons. So what about the rods? Now, if you have to take these pistons to a machine shop to R&R on your old rods, because they were pressed on, they got to be pressed off and pressed back on again. Then they're going to want to recondition your old rods. By the time you get out of there, you can buy yourself new rods and new pistons. So that's what Will decided to do. We bought brand new rods, and these rods are full floating rods. They got a bronze bushing in the top of them and an oil hole drilled to feed oil into them, because the idea of these is the pin can float freely, free floating rods, and the pin can rotate. That takes a little bit of heat and friction out of the engine, and gives you a little more, you don't have to worry about a pin seizing up or whatever. So now, when you get them, that's great. So we got them, we opened up the box. The pin doesn't fit in the rod, so we did a little bit of homework, and you got to hand hone the bushing until it fits. So same tool as we use for the valve lifters, okay? The little hand, this is actually a brake cylinder hone. It works just fine, that's all you need. And we've already done, Mike and I used my rod vise here the other day. We've already done one. We've got to do a little bit more on it, but it's probably 5 minutes a rod. We can get enough clearance just so the pin will float in there. So that's pretty good. And then now what? Now you need spiral locks. So because they're full floating rods, the rod floats in the pin. Normally, the fit between the rod and the pin, the rod and the rest pin, is what locates it in the engine. Now you don't have that. So now you have to use what's called spiral locks. And where did I put that piston? Did I put it over here? Okay, trust me. There's a groove in the piston, and if you're going to use a full floating rod, you need to have a piston with a little groove, which can allow you to use spiral locks. And if somebody's interested in looking into that, there's lots of videos of how to install spiral locks. It's not a fun job. It's very frustrating. The first time you try it, you're probably going to think, there's no way this is going to go in here, but it does. And after you get a couple, you figure it out, and the rest aren't too bad. I've done lots of them, and they're never fun. But you need spiral locks. So when you get the pistons, they don't tell you that. They shows up without the spiral locks. So good thing we were at Bill's yesterday when we made the video on his cam doctor, and Bill saved me. He had a bunch of spiral locks in stock. So we've got that problem solved. So one of the jobs we got to do, using my rod vise, hone the small end of the rod until we have a good fit, a sliding fit between the rod and the pin, and then put the spiral locks in. And when you do that, then the next thing you have to do, when you locate the pistons and rods in the engine, if you come over here, Alec, maybe it'll be helpful. So have to remember, if we're on number one side, so on number one side, the piston's always forward. Number two, it's behind it. So 1, 3, 5, and 7 on the crank is forward. So the rod has got a radius on one side, and that radius is so it can fit against the radius of the crankshaft. The other side is flat. The other side, the flat side, fits against the other rod. So when you install the piston on the rod, this little dot indicates the front of the piston. So you need to have that going on for you. And you need to install the rod then with your radius on the front on this side, 1, 3, 5, and 7. When you go on the other side, you still have the piston facing the front. And now you have the rod with the flat side, okay, facing that way, facing the other rod. And that radius goes on the back of the crankshaft. So got to get that right. It's pretty darn important. So we'll get that all figured out. We'll actually number them all before we put it together so we don't get mixed up. It's not hard to get confused and forget where you are. So that's pistons and rods, crankshaft. So we're building it from the bottom up. Oil pan, it's the Corvette. So we bought an oil pan, the right part number. Mike did a bunch of research. If you go on the forums, this is the pan to use. The part number says it fits the Corvette. It'll fit the block, but Corvette pans are shallower and the sump on the pan is longer. And where the oil pump fits in is at the front of the pan instead of the back. So I could not use this oil pan. So it looks like I got an oil pan in inventory if anybody wants to buy one. And we were not going to use the oiled oil pan. I do not sandblast or get oil pan sandblasted. There's just too many little crevices that the sand media can stay stuck in and get into your oil. So what are we going to do? So Mike took because this pan's not going to work. If we order another one, we're going to get the same pan. So it's a dilemma. So Mike took the old oil pan home, spent 4 hours with his not sandblasting, a high pressure power wash, and a whole bunch of things he did. We'll show he's still got it there. We'll show the pan in the future. And the oil pan wasn't leaking or anything like that. It was just to make it look nice, to paint it, there was too much grunge on it. So if the pan's upside down and you clean it that way and you make sure there's no sand media in the pan, it's going to be okay. So I got a pan in inventory. So that's happens sometimes. Things don't always go perfect at Gold's Garage. So bearings, these are Summit bearings. These are actually made by rod main bearings, standard bearings, not oversized. I will, Mike, and with a dial bore gauge, check the clearance. I'll record every clearance on an Excel spreadsheet. Will get an Excel spreadsheet. He'll know the dimension of every single part in this engine. These are made by King bearings. King bearings are just fine. They'll work just fine. So we got the cam bearings, the main and rod bearings, piston rings, sealed power, chromoly piston rings. And you can use cast rings, but chromoly is a little nicer. That's why you need the finer finish, the 400 finish with the grit if you're going to use chromoly. If you're just using cast rings, you can stick with the 220 grit would probably be okay. That's my opinion anyways. Gaskets, so because we don't buy a complete gasket set, this is for the timing cover, the oil seal, the timing cover we're going to use. I just have one in stock that Will's going to buy, a chrome timing cover. That's the oil seal, water pump, all that stuff. That's pretty straightforward. A new Cloy's timing gear and chain set, complete, of course. That's one part. We are going to use the oil pump over again. I haven't inspected it yet. I haven't cleaned it. I haven't do it, but most of the time, unless the oil they had a hard life, the oil pumps are usable. For rocker arms, if you watched our video with the 406 build that we made 2 weeks ago, these are GM Performance rocker arms, and they're forged aluminum. If you buy this, if you talk about overkill, these are very, very expensive as well. But I have some, so these are going to be used. They were on my race car, and if you looked at the video, we ended up with 8 on the intake 1.6 and 8 on the exhaust 1.5 on the 406. So this is the other half. This is the other 8 1.5s and the other 8 1.6s, which I happen to have. So we'll do the same thing. We'll use 1.5s on the intake, 1.6 on the exhaust. We're going to dyno this engine. Not sure if we're going to experiment with that again, but we might. So the next thing is sort of building my way up here. Head gaskets. So ideally, we're going to have about 30 thou, and I got to confirm that with the new pistons. I haven't done that, but I'm thinking with the new pistons, probably 30 thou down the bore. And so we cannot use the 15 thou head gaskets, the stainless steel head gaskets with those heads. So if you use the 39 thou head gasket, your quench is going to be too thick and it's going to take some compression out. So these are Cometic multi-layer steel gaskets. They're 23 thou. So we're probably going to have a quench around 50 thou, maybe thousandths of an inch. I say it's thousandths of an inch, or maybe a little bit more. We're going to have a static compression around 10 to 1. It's going to be completely safe. You'd like your quench to be as little as it can be, but there's a lot of engines running around with 70, 80 thou quench, and they're working just fine. So that's what we're going to have. The other choice is the only other way you can fix that is take the block to a machine shop and deck the block, and we're not going to do that. So, and it's not going to be necessary. It's going to be fine. So where are we going from here? So that's the cam bearings. So if you watch my videos, you've seen these before, BraveX distributors. I don't know, this is probably at least the 10th or 12th one I bought. I just got it yesterday. It's about $100 Canadian, and they're 65,000 volts, 7,500 RPM. We're never going to get anywhere near there. They work just fine. I've used lots of them, and that's what we're going to use. The distributor that Will had probably would work, but it was a distributor, as I mentioned, with the idea of the GM computer-controlled fuel system. So it had a whole bunch of gimmicks connected to the carburetor, and so we weren't able to use that. So a new dipstick. The dipstick tube was not usable. One-piece timing gasket, or oil pan gasket. So I didn't open that. We'll open that fast. So once again, we don't buy complete gasket sets. We buy a gasket at a time, okay? And here's why. These gaskets are one piece. You can reuse them, and they do not leak, and you don't have to use any Permatex. If you're going to use the other little cork gaskets, you got to use Permatex. If you put any kind of torque on them, they ended up getting squeezed out. So I exclusively use one-piece oil pan gaskets. And so we kind of put our gaskets together, the head gasket, the oil pan gasket, the timing cover gasket, and we don't buy gasket sets. That's the way we do that. Valve cover gaskets. These are the premium ones. We're going to try these. I've never tried this style before. The standard cork ones, if you buy a gasket set, are not very good. So these look like they got some form and shape to them, and we're probably going to be okay. Will's valve cover gaskets, he's going to be refinishing them, or valve covers, I mean. He's going to be they're the original Corvette ones that came on. He wants to keep that original, so they're going to be refinished. They're not handy to show you right now. That's that. So carburetor. So this is, we also bought this 670 Street Avenger Holly carburetor with vacuum secondaries, and I recommend anybody using a Street that's got electric choke, vacuum secondaries, and 670. So even with my 406, it made 500 horsepower with a 650 carburetor. So this is plenty of carburetor. I have exactly the same carburetor on my Camaro, and the one on my Camaro is actually a 770, and I use that because when GM builds those great engines, that's the carburetor they use. So, however, the dyno's telling us that 670 is going to be plenty. So we got a brand new Holly carburetor. Will wanted us to tune the engine with the carburetor that's going to be on it in the car. So there it is. So I may have forgot something, but I got lots of stuff in here. I think I've covered a lot. Give me your likes, subscribe. Don't forget that, and give me comments if there's something I missed, something you want to know. We'll try to put together a parts list for you if anybody's interested and wanting to do this himself. That's the way we did it. There's other videos on YouTube about budget builds now, and that's great. You should watch them all if you want to learn, because everybody has a different point of view, different way of doing it, and then you can make your own decision after you do the research. I didn't mention camshaft. One more thing. The camshaft's not here. Actually, Mike has it now, but I don't have it here. So that camshaft number, it's a Howard's cam. We'll put the numbers in the description. I think we did mention it before, but it's 470 lift, 231 on the intake, 241 on the exhaust. So a little more camshaft than our other budget build, but we needed to do that because those heads like even more than that. We have 10 to 1 compression. So Will only wanted 350 horsepower. I hope I'm going to get myself in trouble and make too much. We'll see what happens, I guess. So that would be a problem to solve. How do you fix that? Well, you put a 390 carburetor on it. That'll fix it. Or yeah, 390 CFM carburetor on it. That'll take enough horsepower out of it. Getting rid of horsepower is not a problem. Getting more horsepower is a problem and expensive. So that's where we're at with Gold's Garage. As we make progress, we'll make more videos as this thing goes together. I'll show you as much detail as I possibly can. I need the likes of Alex or Mariana around or Mike to do this for me. I can't do it myself when I'm not going to hold the camera on myself. That doesn't work. So we're going to try and make videos, good quality videos for you that you can learn by. And you have any questions, let me know. And once again, one more time, like and subscribe. Thank you for watching Gold's Garage.